Okay, Chapter 2, Section 3 and 4 is what we're going to cover in this video. So the first part, we're going to talk about how to divide fractions and how to solve practical problems involving fractions. So we've got a little example right here that says 8 divided by 4 with 8 over 4. Okay, and it says 4 is the divisor. 4 is the thing that we are dividing by. 8 is the dividend. 8 is the number that is being divided. So those are just some definitions. So in the division of 5 divided by 1/2, which number is the divisor? Okay, so the divisor is 1/2. Divisor is the number that you are dividing by. The division 5 divided by 1/2 read 5 divided by 1/2. Ask how many 1/2 unit lengths are included in a length of 5 units. Okay, so if I listed out 5 units, 1, 2, 3, 4, 5, and I look at one of those units. Okay, well, if I divide one of those units into half, you can see that there would be 2 in each one. So there would be 2, right? If we take this and divide it in half, we'd have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So there would actually be 10 units if we did 5 divided by 1/2. Because we're taking those 5 units and we're asking how many 1/2s are in there. Okay, so division answers the question, how many of the divisor are in the dividend? Well, 8 divided by 4 is asking you how many times 4 is in 8. It's easy to see that 8 divided by 4 is going to be equal to 2. So 5 divided by 1/2 asks you how many 1/2s are in 5, and we had an example up here. So if we had 5 things and we took them and divided them all into halves, there would end up being 10 of them. And here's a better picture down here. They've taken our 5, they've taken our 5 things and divided them into half, and you can see it pretty lot clearer than I drew it up there, that there's going to be 10 1/2s in that 5. Reciprocal is a very important term when we're talking about fractions. And reciprocal is simply taking the fraction and flipping it upside down. So normally a fraction consists of a numerator and a denominator. The numerator is on the top, the denominator is on the bottom. And if you're looking at the reciprocal, you're inverting the fraction or flipping it upside down. So if I wanted to say, well, what is the reciprocal of 5/6? The answer would be 6 over 5. We're inverting it, flipping it upside down. The reciprocal of 1/4 is 4 over 1. And most people would just say that that is 4 divided by 1 is just 4. Okay. The reciprocal of 8, well, 8 looks like it's not a fraction, right? So to get the reciprocal, we would write, well, 8 is really 8 over 1. And the reciprocal of that, if I flip it, it's going to be 1 over 8. Okay, so that's how you write a reciprocal. When we're dividing fractions, we can now use the following simple rule to divide fractions. To divide by a fraction, you multiply by its reciprocal. Okay, so when we start out with this first one, the first thing I would do is take this 5 and write it as a fraction like we did before. Put 5 over 1. Then to follow the rule that they told us to follow, right? To divide by a fraction, multiply by its reciprocal. You take the division sign and turn it into a multiplication sign, and then you multiply by the reciprocal of 1/2. If you turn 1/2 upside down, it's going to be 2 over 1. 5 times 2 is 10. and 10 divided by 1 is just 10. Okay, so if we want to do this one, we're going to start out with 2/5. You don't do anything to the first fraction. You take the division sign and turn it into a multiplication sign, and then you take the 4/3 and write down its reciprocal, so we're going to flip that. Now, we talked about this before. It's smarter to go ahead and reduce up front than to have to reduce in the end. So if there's anything that has anything in common with 2, so I'm noticing that the 2 and the 4 have something in common. If it's on the top and the bottom, we could say, well, 2 divided by 2 is 1. 4 divided by 2 is 2, so those two had something in common. The 3, there's nothing on the bottom that has anything in common with 3, so 1 times 3 is 3, 5 times 2 is 10, and then that's already reduced. There's nothing that will go into 3 that will also go into 10. Okay, now, this first part, we're going to write down 5/8. Now, divided turns into times, and then I feel like we might have a problem with this because we can't just say multiply by 3 3/4 here. We need to make this into an improper fraction. So let me just review over how to do that. You take the number on the bottom and multiply it by the number out front. So we're going to do 4 times 3. And then you add whatever is on the top, so plus 3. So 4 times 3 is 12, plus 3 ends up being 15. So we're going to multiply by 15 over 1. Okay, now, I just made a mistake, right? Because, sorry about that. Mistakes are good, though, sometimes, because then we realize what we're doing wrong. So we're all probably going to make mistakes. I needed to slow down. So we're coming up with 3 3/4 is 15 over 4. That's where we messed up right here. So 4 times 3 plus 1 is 3. We got 15. And then so 3 3/4 is 15. And then the denominator stays the same. It's going to be 4. So 15/4. Well, we need to multiply by the reciprocal, which is 4 over 15. Does 5 have anything in common with 8 or 15? Yes. I can divide 5 by 5, and I can divide 15 by 5, and I would get 3. Does 4 have anything in common with 8 or 3? Yes. I can divide 4 by 4 and get 1. I can divide 8 by 4 and get 2. So on the top, it looks like I've got 1 times 1, 2 times 3, and I would get 6. Okay? So why do we need to, so you may be that student who is asking, why do we use reciprocals when we divide fractions? And this gives an explanation of that. So feel free to read that if you're curious about that. Okay, so an electrician has 5 spools, each containing 10 feet of wire. So that's important, 5 spools containing 10 feet. And he needs, so let's just go ahead and figure out that. So 5 times 10 feet, that's going to be 50 feet of total wire. He needs to cut pieces of wire that are 18 1/4 inches each. He wishes to know how many pieces of the length he can cut from the spools. Solve this problem. So he's got a total of 50 feet. Now, one thing that's going to happen is if the spool runs out of wire, then, in other words, we're going to have to figure out how many of these things are happening in each one of the spools. So we need to really focus on the 10 feet first. And we need to know how many times 18 1/4 inches goes into 10 feet. So we're going to need to divide. Well, in order to do that, we are going to want to multiply 10 feet times 12 inches per foot, right? Because we've got to change this to inches. Our unit needs to be the same. That's going to give me 120 inches. Okay, now I can take my 120 inches and divide it by 18 1/4 to see, well, how many is going to be able to, because the spools are not linked together, right? So in one spool, what would I be able to get out of that? Well, we can't divide. We already know we've got to do something to this. We need to change it. I'm going to come up here and change that to an improper fraction. And remember, you take the 4 times the number out front, and then you add the number on the top. Going to add that. So we're going to say 4 times 18 plus 1. Okay, and 4 times 18 plus 1 ends up being 73. And then we're going to put that over 4 when we bring it down here. So we want 120 inches divided by 73. I don't even know how I did that. (73 over 4). Okay, so we're going to say 120, and this is in inches too. So 120. I'm going to go ahead and put it over 1. Turn the division into a multiplication, and then we want to do the reciprocal of 73 over 4. And these things don't have anything in common. In other words, 4 doesn't have anything in common with 1 and 73, and 120 does not have anything in common with 1 and 73. So we're going to multiply straight across. 120 times 4 is 480 over 73. 1 times 73. So we actually want to figure out, I'm going to kind of come over here so I can finish this. We actually want to figure out, well, what's 480 divided by 73? This is a divisor sign, the fraction sign. So 480 divided by 73 is 6.575, and it just keeps going, right? Okay, so basically I don't have enough to get 7 of these out of one spool. I only can get 6 out of one spool. So, but I have 5 spools, so 6 times 5 would give me 30. So they're asking how many whole pieces of this length. This is how many? 30 pieces. We can get 30 pieces that are 18 1/4 inches. Okay, so that was 2.3. Now let's talk about 2.4 really quickly. We're going to talk about adding and subtracting fractions, and we're going to solve some practical problems with fractions. So we've got a picture of adding 1/5 to 3/5 down here. So if you'll notice, there's 5 things, so we're adding 1 of those to 3 out of 5, and we're going to get 4 out of 5 when we do that. So if the denominator is the same, it makes our lives really easy, because we just can go straight across. 1 plus 3 ends up being 4 over 8. The denominator stays the same. And we can reduce that fraction, right? Because we could divide the top by 4 and divide the bottom by 4. And 4 divided by 4 is 1. 8 divided by 4 is 2. So 1/8 and 3/8 is 1/2. And they've got a picture of it down here. 1/8, 3/8 ends up being 4/8. And you'll see right here that that is 1/2. Okay, so here's another easy one. It's easy because the denominator is the same. When you're multiplying and dividing, we don't care what the denominator is, but when you're adding and subtracting, they all have to be the same in order to do that. So when we add this, the bottom's going to stay 12. We're going to say 3 plus 1 is 4 plus 5 is 9. Okay, then we're going to ask if we can reduce this. Well, at the top and the bottom can be divided by, both be divided by 3. So that's going to leave me with 3/4. That's going to be our answer. Okay, what happens when we've got mixed numbers? So there's several different ways we can do this. I am noticing that my denominator is the same, so I'm going to come over here and say 2 1/5 plus 3 3/5. So put my 5 down here. The 3 and the 1 turn into 4. The 2 and the 3 turn into 5. Now sometimes we might have to carry, but we didn't have to in this case because we didn't have more than 1 on this fraction. Let's look at this one. So let me come over here so I have a little bit more room. So 1 5/8 plus 3 7/8. Well, we've got 8. 7 and 5. Well, here's the deal. 7 and 5 is 12. And I can put a 12 right here. Let's just talk about what that is. 12 eighths. Okay? That's more than 1 because 12 is bigger than 8. How many more? 4, right? 12 is 4 bigger than 8. So I had enough for 8 to go into 12 one time, so I would actually carry that 1, and I had 4 left over. So there's my 4/8. So 1 and 1 and 3 is going to be 5 and 4/8. Now, 4/8 is the same thing as 1/2, so that was 5 and 1/2. Okay. So a least common denominator. How do you know what number to use as the new denominator? Well, we want to use the least common denominator, but there's other things that we could use. It doesn't always have to be the smallest one we can find, but we'll talk about the best strategy is to find the least common denominator. So suppose that we want to add the fractions 1/8 and 5/12. Well, this makes it more difficult because these numbers are not the same. So I want them to be the same so that I can add them together. So we're going to look at 8. Okay, 8, I'm going to look at the prime factors of 8. Prime number is a number that only 1 in itself can go into. And so if at all possible, I always start with 2. Will 2 go into 8? Yes, 4 times. Is 4 prime? No, it's not, so we keep going. 2 will go into 4 2 times. 2 is prime, so 8, right? 8 is basically 2 times 2 times 2. Now let's look at the other denominator we had down here, which is 12. So will 2 go into 12? Yes, 6 times. 2 will go into 6 3 times. 3 is prime, so we can stop. So 12 is basically 2 times 2 times 3. So what we're doing is we're looking for a number that both 8 and 12 will go into. And I'm using this strategy to find my least common denominator. Okay, which is also going to be the least common multiple. So what you want to do is you want to find our least common denominator, we want to compare these two lists and ask yourself, what's the most amount of 2's I have in either list? Well, this one has 2, and this one has, this one has 3, and this one has 2. So you want to list it the most amount of times it is in either list. Okay, then there's no other numbers here, so I don't worry about anything with this one. But this one also has a 3. So the most amount of 3's I have in either list is 1 or none. Well, 1 then. So we've got to list 1, 3. Then we would say 2 times 2 times 2, which is 8, times 3 is 24. So our least common denominator that both 8 and 12 will go into is 24. Now, how do we figure out what the number on the top is? Well, we use what we did already in this class when we said, I need to I need to multiply by something that's going to get me 24 on the bottom. So 8 times 3 gets you 24. Well, if you multiply by 3 on the bottom, you've got to multiply by 3 on the top. And 1 times 3 is 3. So this turns into 3 over 24. We need to do the same thing with the 5/12. We need to say, okay, we got 5/12. What would we multiply that by so that we have 24 on the bottom? 12 times 2 is 24. If you multiply the bottom by 2, you've also got to multiply the top by 2, which is going to give me 10. So that's going to be 13 over 24. That's going to be my final answer because that won't reduce. Okay? So let's just practice finding the least common denominators of these numbers. So the first number I have is 12. 2, I always start with 2. You want prime numbers. 2 will go 6 times. 2 will go into 6 3 times. 3 is prime, so I can stop. We look at 45. 2 will not go into 45. I move up to the next prime number, which is 3. 3 will go into 45 15 times. 3 will keep working. 3 will go into 15 5 times, and 5 is prime. So 12 is 2 times 2 times 3. And 45 is 3 times 3 times 5. And remember, we have to list them. We have to look at both lists and list the most amount of times it's in either list. So I've got 2 2s here. It doesn't matter that I don't have any over here. I want to list the most amount of times. So 2 or none, we would list it 2. I've got 1 3 or 2 3s. Well, 2 3s would be the most it's listed in either group. I've got no 5s and 1 5, so I have to list the 5. So when we multiply this stuff out, 2 times 2 times 3 times 3 times 5, we get 180. That's going to be the least common denominator of 12 and 45. Okay, let's look at this one. They want the least common denominator of 4, 10, and 15. So 4 is just 2 times 2. 10, 2 will go into 10 5 times. 5 is prime, so we can stop. 15 is 3 times 5. The numbers on the outside have to be prime. So we're looking at 2 times 2 for this one, 2 times 5 for this one, and 3 times 5. What's the most amount of 2s I have in any list? It looks like 2. Okay, what's the next number I see is 5. Looks like the most amount of 5s I have is 1 in any of, if you compare the 3 lists. The most amount of 3s I also have 1 3. 2 times 2 times 5 times 3. So 60. Okay, that's the least common denominator. That's the smallest number that 4 and 10 and 15 will all go into. Okay, now let's use this when we're trying to add numbers that don't have common denominators. Okay, I've got 2 and 3 8s plus 3 and 1 6. Well, the first thing I'm going to do is I'm going to change this so that these are improper fractions, so it's a little bit easier for me to work with. So, you don't have to do that, but that'll kind of get you to get the whole answer in the end the right way. We could line them up like we did before, but we're having to go ahead and change it, so I'm going to do it all in one step. So to get an improper fraction, you're going to say 8 times 2 plus 3. Okay, 16 plus 3 is 19 over 8. Okay, 6 times 3 plus 1 is going to be 19 over 6 this time because we had 6 on the bottom. So we're adding these two numbers. So we need a common denominator, the least common denominator for 8 and 6. Well, let's look. 8, you can divide 8 by 2. So 8 is 2 times 2 times 2. 6 is just 2 times 3. So what's the most amount of 2's I've got in either list? I've got 3 is the most amount of times, and I've got 1 3 I need to put. So that's going to be 24. That's going to be my new common denominator. So I'm going to have to think about this. I need to multiply this by something that's going to give me 24 on the bottom. So 8 times 3 is 24. If I multiply the bottom by 3, I also have to multiply the top by 3. 19 times 3 is 57. I need to multiply by something that's going to make the 6 be a 24. 6 times 4 is 24, so that means I need to multiply the top by 4. Okay, 19 times 4 is going to be 76. Okay, and now I can add straight across. We've got 24 on the bottom. 57 plus 76 is 133. And if we don't want an improper fraction, we would divide. Remember, we'd say 133 divided by 24. Okay, it'll go 5 times. And then 5 times 24 gets me 120. So the difference between 133 minus 120 gets me 13. So that's going to be 5 and 13 24ths. That's going to be my final answer on that. Okay, so we've got 5 1/2 plus 3 2/3. We're going to change them to improper fractions. 2 times 5 is 10 plus 1. That's going to be 11 over 2. 3 times 3 is 9 plus 2. It's going to be 11 over 3. So we need a number. These are both prime already. So we could just do 2 times 3 here and make both of these 6. 2 will go into 6 3 times. So if we multiply by 3 on the bottom, 2 to get 6, we get 2 times 3 is 6. We would multiply by 3 on the top and make that 33. 3 will go into 6 2 times. 2 times 11 is 22. Okay, that's going to be 55 over 6. And if we want to divide that out, we're going to ask, well, how many times will 6 go into 55? And then find the difference. Okay, so we want to make that into a mixed number. It's going to be 9 and 1/6. 6 will go into 55 9 times with 1 left over. So 9 and 1/6. A construction plan calls for a stud that's 3 1/2 inches thick to be covered on both sides with a 3/8 inch sheetrock. The contractor needs to know the total thickness as the result. So basically we've got something that is, we've got the sheetrock that's 3/8 plus we've got the stud that's 3 1/2. These are all in inches. Plus we've got another thing of sheetrock that's 3/8. Okay, so basically these two are already the same. So I could go ahead and put those two together. That's going to give me 6/8 for that. Now, let's go ahead and change this to an improper fraction. 2 times 3 is 6 plus 1. So 7 over 2. Now, We can use the strategy we did a while ago, but we need a number that both 8 and 2 will go into, and 8 will work, right? Both 8 and 2 will go into 6. How many times will 2, what would we have to multiply 2 by to get 8? Well, 4. So we're going to have to multiply the top. 7 times 4 is 28. That's going to be 34 over 8. Okay, now we need to change that. We need to ask ourselves, well, how many times will 8 go into 34? Well, 8 times 4 is 32. So we would have 2 left over. So 32, I'm sorry. Eight will go into 34 4 times, because 4 times 8 is 32. So we got 4 and 2 8s left over. So 2 8s, we could divide the top by 2 and the bottom by 2. That would get me 1/4. So the total for the whole wall, if we add all that stuff up, would be 4 1/4. Now, what do we do when we subtract? Well, pretty much the same thing. You've got to have a common denominator. So let's just think about this. What's a number we're going to look for the least common denominator. We can use a strategy we used before, but a number that both 4 and 5 will go into, well, that's going to be 20. 4 will go, so you'd ask yourself, what do we multiply 4 by to get 20? 5, so 5 times 3 gets me 15. What would I have to multiply 5 by to get 20? 4, and 4 times 1 is just 4. So 15 take away 4 is 11 20ths, right? Okay, and that won't reduce. Okay. If this one already has a common denominator, which if it already has one, we might be able to work this problem like this, make it a little bit easier on ourselves. 5 minus 1 is 4. Then we got 4 6. 5 minus 3 is 2. This can be reduced because both of these can be divided by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So 2 2/3. Okay, if I want to do 6 1/4 minus 1 3/4, okay, this is a little bit more challenging. You might want to go ahead and make them in proper fractions on this one. It might help you out because you can't say 1 minus 3. So I'm going to go ahead and do that. 4 times 6 is 24. 24 plus 1 is 25 over 4 minus 4 times 1 is 4 plus 3 is 7 over 4. And 25 take away 7, we're down to 18 fourths. Okay, 4 will go into 18 4 times. 4 times 4 is 16, so we would have 2 fourths left over, and 2 fourths is 1/2. Okay, we've got 3 1/2 minus 1 1/3. I'm going to make it an improper fraction to start out with. 2 times 3 is 6, plus 1 is 7 over 2, minus 3 times 1 is 3, plus 1 is going to be 4/3. Okay, so I need something that both 2 and 3 will go into. Let's change that to 6. So I would have to do 2 times 3 to get 6. So I'm going to have to multiply the top 7 times 3 and get 21. 3 times what gives me 6? That's going to be 2. So I'm going to have to multiply the 4 by 2, which is going to be 8. 21 take away 8 is going to be 13 over 6. 6 will go into 13 2 times. 6 times 2 is 12, so we would have 1 6 left over. Okay. 5 1/4 minus 2 3/8. So I could just go ahead and change this. This is going to, if this is an 8, but Let's make this an improper fraction. So 4 times 5 is 20 plus 1, so 21 over 4. 8 times 2 is 16 plus 3, 19 over 8. Now both 4 and 8 will go into 8, so really we only have to change the first one to have an 8. 4 times 2 is going to give me 8. So 21 times 2 would be 42. 42 take away 19, got 23 eighths. 8 will go into 23 2 times. 2 times 8 is 16, so we would have a remainder of 7 eighths. Okay. If you are subtracting a whole number from a mixed number, you just want to simply subtract the numbers in their original form. So if we have 4 and 5/16 and we want to subtract 2, we don't have any fractions here. We can just put 5/16 and 4 minus 2 is just 2. That one's kind of easy. Okay. Order of operations with fractions. When a calculation with fractions involves 2 or more operations, be sure to follow the rules of order of operations. So the please excuse my dear Aunt Sally, parentheses, then exponents, multiplication, division first, and then addition and subtraction. So I have to do the division before I do the addition. So the first part is what I've got to take care of. So 11 over 16, remember change the division to a multiplication, and then remember you can write 4 as 4 over 1, so we're going to do the reciprocal of that. That's going to get me 11 over 16 times 4, which is going to be 64. Okay, now we can do the addition. So 5/8 plus 11 over 64. 8 and 64, 8 will go into 64, so I know that we could just change our least common denominator. We could make it be 64. So how many times would we have to multiply 8 to get 64? 8 times 8 is 64. That means we'd have to multiply 8 times 5 and get 40. So that's going to be 51 over 64. Okay, and I don't think that that's going to reduce. And it's not an improper fraction, so we can actually stop right here. The cross-section view of a pipe is shown in this figure. The pipe has a 2.5 inch outside diameter, so it's basically drawn from here to here, and the wall thickness of the pipe is 1/8 inches through here. A plumber needs to know the inside diameter, so basically he's looking for this part that is right here in the middle. So we are going to have to start off with the whole thing, the outside diameter, and we're going to have to subtract off both of these 1/8. Okay, so 2 times 2 is 4 plus 1 is, so 5 over 2 minus 1/8 minus 1/8. Now I can make that 2 times, so we need them to all be the same. And so 2 times what is 8? 4. 4 times 5 is 20. And I don't need that extra 8 right there. Okay, so that's going to be 18 over 8. We can reduce this fraction, and so that's going to be 9 over 4, which is 2 1/4 inches. Okay, so 2 1/2, if we subtract off an 1/8 and an 1/8, we're going to get 2 1/4. That's going to be our inside diameter.